All right, this example says determine the gravitational force between the Earth and the Sun when separated by 1.5 times 10 to the 11th meters. Now these are the values for the mass of the Sun, the Earth and the Sun, so we should be able to figure out what the actual gravitational force between the two is. So we are looking for Fg. Now since I'm looking for the gravitational force and I have two masses separated by a distance, I know that Fg equals mg will not work. Instead I'm going to have to say, well, the gravitational force is equal to g, which is the universal gravitational constant, m1, m2 over d squared. So now we can get our given information. We were given the mass of the Earth. I'll call that m1. The mass of the Sun. And we were given the distance between the two. Now, so if we were to draw this out, we would see you have the Sun, which is very, very large, and the Earth, which is much, much smaller, and there's a distance of 1.5 times 10 to the 11th in between them. You should realize that they are both attracted to each other with the same gravitational force, which is what we're trying to calculate. Now the effect on the Earth is going to be much, much larger because the Earth is very, very small compared to the Sun. So before we move on, a lot of people might be hung up on why I decided to make the Earth mass 1 and the Sun mass 2. It actually makes no difference. If you look at the formula, you're going to multiply the two together anyway. So just as a simple example, if I take 5 and multiply it by 4, I get the same thing as if I take 4 and multiply by 5. So don't be caught up in terms of what's supposed to be M1 and what's supposed to be M2. You can just assign them however you're more comfortable with. So now we can plug in our values. Remember, G is a constant. We can always find it on the star reference chart, or we can just say that it's 6.67 times 10 to the minus 11th multiplied by 5.98 times 10 to the 24th times 1.99 times 10 to the 30th, and all of that is divided by 1.5 times 10 to the 11th, and that is squared. So if you can't tell already, it is very, very important for these questions that you actually be able to solve or be able to enter these exponents into the calculator well. Now for some reason, because people see times 10, they automatically try and do that in the calculator. Please don't do that. If you have a calculator, what you want to do is you want to use the exponent button, which on the TI graphing calculator is the double E button, which is just above the 7. So I would enter that as 6.67 second comma, which gives me that E, negative 11 times 5.98 E24 times 1.99 E30, and now I can take that whole thing and I can divide it by 1.5 E11 squared. When you do that, you get a value of 3.53 times 10 to the 22nd newtons, which is a very, very large value. But it's something that we should expect. I mean, if we're looking at what is keeping the Earth moving in a circle around the Sun, we would expect it to be a very, very large value. And it is.